Welcome to the examples for section 5.4. I'm going to go ahead and start off with number 20. Now, when we do in this section, it's going to be slightly different than what we did in the previous section. So when you have a quadratic inequality, we have to solve it slightly different. So here we have x minus 5 times x plus 2 squared is greater than 0. So what we're looking for is we're looking for the values of x that will make this greater than 0. And so first thing that you do is we're going to set each of the factors equal to 0, and we're going to go ahead and solve. So we get x is equal to 5. And then the other one here, we get x plus 2 squared is equal to 0. We square root both sides, and we get that x is equal to negative 2. Now, when we do this, we're going to go ahead and have to create a table of our values to find out where is this greater than 0. And so if you notice here, we have a negative 2 and a 5. So this is, when x is negative 2, this will be 0. And when x is 5, this will also be 0. And so we're going to create our intervals. And the first interval that we're going to have is negative infinity to negative 2. And then negative 2 to 5. And then 5 to positive infinity. And then in each interval, we're going to choose a test point. So we go from a negative 2 to a 5. So 0 is in this interval, 6 is in this one, and negative 3 is in this one. Then we're going to go ahead and calculate the value, or whether it's positive or negative, of this expression here at each one of these test points. And so the first one that we're going to do is we're going to go ahead and pick negative 3. So we're going to plug in negative 3 to each one of these two factors. And then you can see that if we get negative 3 minus 5 times negative 3 times 2 squared, so we're going to get negative 8 is equal to negative 1 squared, which is just going to give us negative 8 times 1, which is a negative 8. And so this is obviously negative, right? And so the solution to this inequality does not lie in this first interval right here. Now we're going to go ahead and test the second one. And so we plug in negative 2 minus 5. Oops, not negative 2, 0, sorry. So we're going to do 0 minus 5 and then 0 plus 2 squared. So here we get negative 5, we get 2 squared, and we can see here that we're going to end up with a negative also, right? And so this is negative 20, and this is also negative. So the solution to this inequality, again, does not lie either in the first interval or the second interval. Now we're going to go ahead and test out the third interval. And so we get 6 minus 5, and then we get 6 plus 2 squared, and 6 minus 5 is 1, and this is going to be 8 squared, and we can see here that this one is positive. So therefore, the solution to this inequality, excuse me, is x is greater than 5, or in the interval notation, which we already have written up there, and 5 to negative infinity. I don't believe that we had to graph it. No, we didn't. All right, so the next one is going to be number 24. And number 24, we're going to go ahead and do the same thing. Now, when we do this one, what we're going to do is we're going to move everything over, excuse me, to the left side. So it's less than the 0. So we have 3x to the third power plus 15x squared is less than 0. So let's go ahead and take out a 3x squared, and when we do that, we end up with x plus 5 is less than 0. So just like we did in number 20, we're going to set each one of these factors equal to 0. And we're going to get our interval. So this one obviously is x is equal to 0, and this one is x is equal to negative 5. So when we create our table, we're going to have the negative infinity to negative 5, the negative 5 to 0, and then the 0 to positive infinity, right? And so we're going to get a test point in each one. So this one, let's just pick one. This one here, we can pick negative 4, and this one here, we can pick negative 6. And so sometimes it's easier just to plug it into this last one. And so if in this one here, of course, it has to be less than 0, right? So I'm going to have 3 times negative 6 squared times negative 6 plus 5. And then so this is 3 times 36 times negative 1. And then you can clearly see that this is going to be negative. So thus far, the negative infinity to negative 5 is in fact a solution to this inequality. Let's go ahead and try negative 4. So we're going to have 3 times negative 4 squared times negative 4 plus 5. And so this is going to be 3 times a positive 16, right? And then this one here, you can see that this one's going to be positive. So this is not a solution to this inequality. And then let's go ahead and try the last one. The test point is 1. So we're going to have 3 times 1 squared and then 1 plus 5. So this is just 3 times 1 times 6. So this, again, is also positive. So then the solution to the inequality, 3x to the third power is less than negative 15x squared, happens to be that x is less than negative 5, or in interval notation, negative infinity to negative 5. All right, let's look at number 28. Number 28, we're going to go ahead and do the same thing that we did previously. And so in this one here, we have x to the third power plus 2x to the second power minus 3x, and that is greater than 0. So what we're going to do here again, we're going to go ahead and take out, so we're going to go ahead and factor this. We're going to go ahead and split it up into factors. So we have x, and then I end up with x squared plus 2x minus 3 is greater than 0, which means that x, this is going to factor into x minus 1, and then x plus 3 is greater than 0. So I'm going to have x is equal to 0 is my first factor is equal to 0, right? And then the second one is x minus 1, so x is equal to 1. And then x plus 3 is going to give me that x is equal to negative 3. So here I have my 3 0 factors, if you will. And so I'm going to go from negative infinity to negative 3. Then I'm going to go from negative 3 to 0. Then I'm going to go from 0 to 1. And then I'm going to go from 1 to infinity. And so I split all these up here. I'm going to write my solution here in the last one. And so for this one here, I mean, we can go ahead and test 1/2. We can do 2 here. Here we can do negative 1. And then this one we can go ahead and use negative 4, right? And so what we're going to do is we're going to go ahead and find the intervals that will make this inequality greater than 0, or the expression on the left-hand side greater than 0. And so if I plug in negative 4 here, I'm going to get a negative 4, and then negative 4 minus 1 is negative 5, and then here I'm going to have negative 4 plus 3. So I have a negative times a negative, which is a positive times a negative, so this one is going to be negative. Now let's go ahead and try the next one, which is the negative 1. So I have negative 1, and then negative 1 minus 1 is negative 2, and then negative 1 plus 3 is a positive 2. And so a negative times a negative is a positive times a positive is a positive, so this is positive. So right now, negative 3, 0 is in the solution for this inequality. Let's try 1/2, right? So we have 1/2, and then 1/2 minus 1/2 is just negative 1/2. And then we have 1/2 plus 3, which is going to be a positive. But a positive times a negative is a negative, right? A negative times a positive is a negative, so this is going to be negative. Now let's go ahead and try 2. So we have 2 here, and then 2 minus 1 is 1, and then 2 plus 3 is 5, so this is obviously positive. And so for this particular one, our solution set, let me go back over here and get rid of this so I can write it. And so our solution set for this one is going to be negative 3, 0 union 1 to infinity. And if we were to write it in an inequality type, it's going to be negative 3 is less than x less than 0, or 1 is x is greater than 1. Sorry, not 1 is greater than 1. X is greater than 1. And so perhaps this is the better one to write your answer as, right? So that's not a solution, that's not a solution, it's the last two. All right, number 40. So number 40, we have x plus 2 divided by x minus 4 is greater than or equal to 1. And so before you do anything here, you want to move everything, all of the constants, everything over to the left side. So I'm going to end up with x plus 2 over x minus 4 minus 1 is greater than or equal to 0. I'm going to rewrite the 1 as x minus 4 over x minus 4 to make my life a little easier. So this is going to be x plus 2, x minus 4 minus x over 4 minus x minus 4 divided by x minus 4 is greater than or equal to 0. And so now I can go ahead and combine like terms. So this is going to be, when I finish writing this one, it's going to be x plus 2 minus x, right, plus 4. So x plus 2 minus x plus 4. And then, of course, my denominator will just be my x minus 4. And so we combine those two, and we're going to end up with, here we're going to end up with 6 over x minus 4 is greater than or equal to 0. And so originally we had x plus 2 divided by x minus 4 is greater than or equal to 1. We have to combine everything. We have to have 0 on the right-hand side. Usually that's the best side to have it on. You want the variables on the left. When we go ahead and combine everything, we end up with x divided by 6 over x minus 4. And so the only time, so this function is never equal to 0, right? This expression is never equal to 0. However, it's undefined when x is equal to 4. And so that's going to be our interval. Our intervals are basically going to be negative infinity to 4, and then 4 to positive infinity. And what we're looking for is when it is greater than 0. And so for this one, we can go ahead and pick 5. For this one, we can go ahead and pick 0. Let's make life easy. Right, so this is going to be 6 over negative 4, and this is obviously going to be negative. Right, and then this one here is going to be 6 over 1, which is obviously going to be positive, right? 5 minus 4. So then the solution for this particular problem here is going to be 4 to infinity. And if I was writing it this way, it would be x is greater than or equal to 4. Let me see something here real quick. Yeah. So here's the issue with this one. We can't put 4, and that's why I don't have the brackets on the 4, right? I know it's greater than or equal to, but we don't put the brackets because 4 is not part of the solution. So it goes from, something greater than 4. And so that's the end of the examples for 5.4.